Hi everybody, this is our very last chapter review. Yay! It's a little bit shorter than chapter 11, thankfully, but the problems are complex. I mean, there's no way around it. You know how to do them, and if you are patient with yourself and just work through the problems knowing that you know what you're doing, you'll be fine. But these are the most complex problems probably of anything that we've done this year. That's why they're at the end of the year. But if you know your formulas and have them in front of you, you can do these problems without any problem. So what will you need to know? You're going to need to know how to identify, first of all, what is a prism, a cylinder, a pyramid, and a cone. Okay, hopefully you've got those well in mind. Okay, then you're going to need to know how to find the surface area and the volume of those things. Okay, prisms, cylinders, pyramids, and cones. And there was a really nice paper that I handed out that had the surface area, the formulas for surface area in all these four objects that I really recommend that you bring to the final. Because it's a really good it's a really good reference. Okay. And then finally, you need to know how to find surface area and volume of composite figures. So that's when we take a cone and add it to a cylinder, or we take a prism and add it to a pyramid. And so you need to find both the surface area and the volume of those composite figures. It means they've been added together. And we'll do a couple of those in this video. Okay. So first we're going to work on volume. Okay, and these pyramids are regular, and the prisms, cones, and cylinders are right. Round your answers to 2 decimal places, just like we always do. Okay, let's look at number 1. I hope I left enough space here. So first of all, you need to identify this, and this is obviously a pyramid. It's not a cone because it doesn't have a round bottom, okay? It has a rectangular bottom, and then it comes to a peak at the top, and so it's not a prism, it is a pyramid. So the formula for the volume of the pyramid is very simple. It's just volume equals base times height. Now, when they're talking about base, they're going to be talking about the part that sits on the table. Okay, that's your base. And in this case, our base, very conveniently, is a square. And so our base is equal to 18 times 18, which is equal to 324. Okay, so that's going to be equal to 324 times whatever our height is. Now, this is something where you have to get really particular. So they give you this height, 41 centimeters, but that's not the height of the solid. That's not the height of the pyramid. That is the slant height. Okay, you remember that from last chapter. Okay, this is the slant height. It's not the height of the prism. Remember, the slant height was equal to that little L. Okay, and H and L are not equal. Okay, H, and I'm going to use yet another color. H is the vertical line that goes down the middle, okay, of the pyramid. Okay, this is H. So the question becomes, how do we find H when we only know L? And hopefully by this point, you have an idea of where we might be going. When in doubt, you draw a triangle. And so let's draw a triangle. Okay, our slant height in this case is going to be our hypotenuse. So it is 41. Okay, our base of the triangle down here is half of this rectangle, so that would be 9 centimeters. 99 is 18. Okay. And then we have our height. So you have a triangle, you know 2 of the sides and you want the third. So what do? You call Pythagoras. Okay, so I have h squared plus 9 squared. 92 squared? I don't think so. 9 squared equals 41 squared. Okay, and you're going to calculate that all out, and your height is going to be 400. Okay, and actually, volume equals 1/3 beach. Sorry about that. Hopefully you guys caught that before I did. Okay. Oops. And that is 40. Okay, and you can work that out for yourself. So this becomes volume equals 1/3 base times height equals 1/3. Our base we figured out, calculated, was 324, 18 times 18. And our height is 40. It is the height of this triangle that we made with the slant height as the hypotenuse. And we used Pythagoras to figure out what h was. H is equal to 40. And if you multiply all of that out, 1/3 times 324 times 40, you're going to end up with 4,320. Okay. And that is your answer. Okay. So I'm going to erase this and then to work on the next one. But I'll leave some of the... Okay. So here we have, first identify it. This is a cone. Okay, it's got a circular bottom, and then it comes to a point at the top, and that's a cone. It's not a cylinder. So we know the volume of a cone. I get my 1/3 in there this time. 1/3 times r squared times h. Okay, so we have, we've got a pi in there. Gosh, come on, Liza. Must be a holiday Monday. Pi r squared h, because it's base times height. Yeah, okay. So 1/3. We have pi. Our r is 3.7, so we're going to square that. And our h. Now, recall, if we tried to take the h out of the middle of the cone like this one is, like the previous pyramid was, we would get the wrong value, because remember, the height has to be perpendicular to the base, and this is not perpendicular. Okay, it's at some weird angle. So what we need is a height that's perpendicular to the base, and so that is this height here, okay, in which they have conveniently given to us, which is 8.9. So there's our height right there. So you multiply all that stuff together, and you're going to get 127.53, or something close to that, depending on what you do for pi. Okay, so those guys are pretty easy, and you're basically just plugging and playing. So let's do next one. Okay, so what is this thing? So it's obviously not a cylinder. There's nothing circular about it. It's not a cone. It doesn't come to a point at the top, and it doesn't have a circular base. It's not a prism or not a pyramid, because it doesn't come to a point anywhere like pyramid does. So it must be a prism. So how do we look at this as a prism? So what I found, okay, is the best thing to do is we're looking for a volume. Volume equals base times height. So I'm going to write down that this is a prism. Okay, so what's our base? So you could think that this and this were a base, but unfortunately you've got all these lines, all these pieces that are going out to the side, and so that really isn't a good base. So a much better base that you should use are these hexagons. 1, 2, 3, 4, 5, 6. These are hexagons. So this face is the base, and then the other base is back here. Okay. Okay, so those are our two bases. So, okay, our height is pretty easy, because if we think about tipping this piece on the side so that this part here is actually on the table, okay, then our height is going to be this distance off the table, which is given as 8. So our h is going to be 8. That's easy to figure out. But now we have to figure this area of a 1, 2, 3, 4, 1, 2, 3, 6 hexagon. Okay, and so in order to find that, okay, you have to remember that the area of a hexagon, or any polygon, is equal to 1/2 the perimeter times the apothem. So let's work on the perimeter first. So we know one side is equal to 7. And we know that in a hexagon there are 6 sides. So my P, perimeter, is going to be 6 sides times 7, okay, equals 42. Okay, so there's my perimeter. So I'm going to have 1/2 times 42 and times the apothem. So how do we find that apothem? As usual, when in doubt, make a triangle. So here we go. We're going to make a triangle here. And we're going to notice that if we made these triangles all the way around, okay, we'd end up with 6 triangles because we have a hexagon. And we know that if we went all the way around here, that would be 360 degrees. So this angle here is going to be 360 divided by 6. So 360 divided by 6 is equal to 60. So from this large triangle, I need to make a half triangle. And we know that this larger this larger angle is 60. When we draw our line, which is this line here, this angle is 30. And we know that this is a right triangle. That's a right angle. And we know that this length right there is 1/2 times 7. So that's going to be 3.5. And what we want to know here is this apothem. So how do we figure it out? Okay, so we know one angle and we know one side. So you're going to have to use good old trigonometry. So look at your trig functions, and we know the function for tangent is tan theta equals, remember from SOHCAHTOA, TOA, opposite over adjacent. Okay, and our theta is 30. Is going to equal the opposite side, which is 3.5, over the adjacent side, the next to side, and that's good old A. So we need to solve for A, so we're going to multiply both sides by A. A tan 30 equals 3.5. A is equal to 3.5 divided by tan 30. Okay, and 3.5 over tan 30 is actually equal to 10.5. You can plug that into your calculator. So now we have our A, so we can go back and figure out our area up here. So our area is 1/2 times 42 times 10.5, the area of our base. Okay. And 1/2 of 42 times 10.5 is equal to 220.5. Hold on, Bessie. Yeah, okay. And if we multiply all that together, you get 220.5, so that's our area. So volume equals 220.5 times 8, and that is equal to 1018.45. And we are done. Okay? So, let's continue. Okay, volume of the solid. So here we're going to work on some volume. Okay, and notice these are what are called composite figures. So what this is, for example, this number 22, so this is a big cylinder, and they've gone and taken a little cylinder out of it. Okay, like they took a plug out of it, like a core sample you do in science. So what you need to do is figure out the volume of the whole cylinder, and then you need to subtract the volume of the little cylinder to get the final volume of that whole figure. So, and you can take, you all know how to do the volume of a cylinder, so that it's not all that difficult. It is complex, but it's not difficult. So we're going to take the volume of the large minus the volume of the small. Okay. So, volume of a cylinder is equal to pi r squared h. So let's work on our first one first. So our large cylinder is equals pi. Okay, we're given that our diameter is 8 meters, so our radius has to be 4. So pi times 4 squared, and we're given our h is 5. And we multiply all that together, and we come up with 251.2. Okay. Now, our small, v small, is equal to pi. Okay, our radius is given as 0.9, so we're going to square it. And then it has the same height, which is 5. So we're going to multiply all that together, and we're going to come up with 12.717. So we're going to V large minus V small is 251.2 minus 12.72. I rounded this. Okay, and that is equal to 238.48. Done. There's your answer. Okay. So the tricky parts here are remembering to subtract and remembering what your how to find your volume. So it's really not that difficult, even though it is definitely complex. Okay, so let's do the next one. Leave that there. And I'll change colors. Need that, need that. Okay, and I'll change colors just for clarity. Magenta. Okay, so here, instead of having, for number 23, instead of having 2 cylinders, we have 2 prisms. And we have a big one and a small one. So we're going to have to figure out the volume of the large, and we're going to have to subtract the volume of the small in order to get the total volume. So V large, okay, and the volume of a prism is base times height, and the base here is 5 times 10 is 50. And then our height is 7. So V large is, volume of the large prism is 350. So the volume of the small is also equal to BH. But we're given that the base would be 1.6 times 2, and our height is going to stay the same. It's 7. Okay, so here's our 1.6 and here's our 2. Okay, so those are rectangles, and that's going to equal to 22.4. So we do V large 5 minus V small. So we get 350 minus 22.4, and that is going to be equal to 327.6. And there's your answer. Okay? So this is probably the caliber of problem that you will see on the final when it comes to composite figures, but we're going to also be working some other ones as we go along here. Okay, so we're going to change now from volume to surface area. Okay, so different set of formulas that you also need to have written down, okay, and available to you during the final. So we see that number 7 here is a prism, and we can leave our base here. The one sitting on the ground, and the surface area of a prism, S, is equal to 2 times the area of the base plus the perimeter times the height. So the area of our base is 9 times 14, which is 252. No, 2 times 14 times 9 is, I'll write that out, 2 times 14 times 9 plus the perimeter. Okay, you're going to have 2 9-feet sides, so 2 times 9 plus, this is all going to be perimeter, plus 2 times 14. This is all P, and our H is 10. So then you just gotta rock your calculator. So this is 2 times 14 times 9 is equal to 252. plus 2 times 9, and I did it slightly differently, but this all ends up to 180 plus 280 is equal to 712, and that's your answer. So you can do this a little bit differently. You have to distribute the 10 across, so it's 2 times 9 times 10 is equal to 180. 10 times 2 times 14 is equal to 280. You add all those up, you get to 712. Okay, it's just a matter of how you did the math. Okay, but you should end up with the same answer no matter how you did it. Okay, so that's that guy. And here we have a cylinder. And we know that the surface area of a cylinder, S, is equal to 2 pi r squared. Okay, that takes care of the area of the two bases, plus 2 pi RH. 2 pi RH. Okay, and that takes care of this part here. Okay. So they've very kindly given us R, and they've given us H. So all I got to do is plug and play. So we have 2 times pi times 3.5 squared plus 2 times pi. We're not squaring R this time, 3.5, and we're multiplying it by H, which is 6.8. Okay, where am I here? So, long story short, this is going to be equal to 76.93 plus 149.46, and it's all going to be equal to 226.39. And we're good, and that's your answer. Okay, those are really simple applications of surface area formula. Okay, 9. Now, this guy is tricky. The number 9 is a little bit tricky, but that's okay. And here we have a pyramid because the base is a hexagon. 1, 2, 3, 4, 5, 6. Okay, and and it comes to a point at the top. So this is definitely a pyramid. And the formula for the surface area of a pyramid is equal to the base, area of the base plus 1/2 the perimeter times the slant height. Remember, we talked about slant height a little bit earlier. And they kindly gave us the slant height, which is 16. So we know what L is. The perimeter we can figure out pretty easily. Our perimeter, okay, one side is equal to 8, and there are 1, 2, 3, 4, 5, 6 sides. 6 sides times the length of 8 is equal to 48. So there we go. We already have our perimeter. And we're only left to figure out the base. Now this is base of a hexagon is a little tricky. So remember that the base is going to be 1/2 times the perimeter times the apothem. Well, we've got the 1/2, we've got the perimeter is 48, and we need to find the apothem. So, how do we find the apothem? Again, when in doubt, make a triangle. And then either use Pythagoras or trigonometry to figure out what it is that you're missing. So, we know the base of the triangle. So here's my triangle right here, which is this guy here. Okay. So I know my base of that triangle is 4. And I need to find out what my apothem is, because that's right there. And I know that I can find the angle there. And so how do I find that angle? Remember, this is the central angle. I'll change colors. Here's the central angle, and I find my central angle by taking 360. So central angle is equal to 360. I'm dividing by how many sides we have. 1, 2, 3, 4, 5, 6 divided by 6 is equal to 60. And I cut it in half because I only want that half of it. So this is going to be 30. And we know this is a right triangle. So yay! Guess what we have? We have a 30, 60, 90 triangle. Okay. So if the base is 4, and this is a 30, 60, 90, and we know the rules for 30, 60, 90. I'll go over them again just in case. So we know the base is x. Okay, we know the vertical side is x times the square root of 3. And we know the hypotenuse is 2a. So in this case, we need to know this, a, which is, sorry, this is 2x. How to confuse you, okay? Is going to be x, which is 4 times root 3. So our apothem is 4 root 3. Okay. And, yeah, okay, so let me calculate that out. Is going to be equal 1/2 base plus 1/2 PA is equal to 166.32. Okay. And so now I'm going to feed that back into this equation. And I know my S is equal to my area of my base, which I know is 166.32 plus 1/2. My perimeter is 48. And we know the slant height is 16. Okay, you do all the numbers on that, okay, very carefully, and you're going to come up with something like 550.32. And there's your answer. Okay, so that was kind of tricky. You had to figure out this area of the base, which means you had to find out the apothem, okay? But then they gave you the slant height, so that helped. Okay, let's go on to the next one. House cleaning here. Okay, what do we have here? Obviously, we have a cone. Okay, and the surface area of a cone is equal to pi r squared plus pi r slant height. Okay, that's L. So, conveniently, they've given us our R. Now, they didn't give us our slant height. This is our slant height. They gave us 8, those slimy dogs. So what do we need to do? We need to figure out our L. And how do we do that? When in doubt, we make a triangle. Okay, you'll be making a lot of triangles. Okay. So we're given that our base is 27. We're given that our height here is 36. And we're looking for our L. So you know two sides. You don't need to use trigonometry. You can use good old Pythagoras. Okay. And if we use Pythagoras, we're going to I'll do it over here, 27 squared plus 36 squared, okay, is going to be equal to 45 squared. Okay, so our L is equal to 45. I shortcutted the math there. Okay, so our S is going to be equal to pi times our R is 27 squared plus pi times just R, not squared, times the slant height, which is 45. Okay, and you do the math on that, and S is going to be 6,107.26. And there's your answer. Okay, so not too bad. You had to use Pythagoras, but that's okay. Yeah, and just remember on here that you know the difference and recognize the difference between the height, which is perpendicular to the base, and the slant height, which comes from the side and goes to the middle, and it's slanted. So that makes sense. Okay. Okay. This guy actually, I apologize if you have been struggling with this, but I think because it was a follow-on to those, I think you may have thought that I wanted you to find the surface area of this, and actually I wanted you to find the volume of this. And so I'm sorry if you spent a lot of time on that. But so the volume here is, this is a prism, right? So we look at what's our base. So our base, okay, these two are slanted. Okay, wait a minute, I won't draw it that way. The tricky part in this is figuring out what's the base and what everything else is. So if we look at these two sides, okay, those are both slanted. Okay, so those cannot be bases because remember the bases have to be parallel, and those are decidedly not parallel. So this leaves us with the possibility of having the top and the bottom of here bases, but the bottom rectangle is obviously smaller than the top one, and remember one of the requirements for a base is that they are congruent. And these two rectangles are obviously not congruent. So that leaves us with these two trapezoids as our bases. Okay? And so here's the trapezoid is our base, and our height. Okay, if you think about tipping this over so that base is on the table, then the height off the table is going to be 8 miles in this case. And so this part, the tricky part with this problem is trying to figure out the what is the base and what is the height. Okay, and again, this is a prism. Okay. And the volume of a prism is V equals base times height. Okay, remember the area of a trapezoid is equal to 1/2 the height times B1 plus B2. So in this case, we have our 1/2. Okay, here is our height of the trapezoid. This is the height of the figure, of the solid. Okay, this is the height of the trapezoid. So the height of the trapezoid is 3.5. Okay, one of our bases is 3, and the other base is 7. Okay, we calculate that out. Okay, and I forget what that is. Hold on, I'm going to pause this and calculate. I didn't write it down. Okay, and obviously I made a boo-boo here. Okay, so B1 is, we can make 3, and this is 3 plus 7, so 1/2 3.5 times 10 is equal to 17.5. Okay, and so the area of our base is 17.5, and we're going to multiply that by our height, which is 8, and we're going to come up with 140. And that's our answer. Okay, so this looked kind of like a really evil problem, but it's not. It wasn't that bad. Okay. So, next. Now, what this does, this type of problem tests your ability to draw a picture based on or draw a figure based on a description. Okay, and or you can draw it or you can visualize, whichever way it works for you. I generally have to draw it because I don't visualize very well, and that's just the way my brain works. So if I have a rectangular prism, that means the bases of my prism are going to be a rectangle. And here isn't a great drawing, but you get the idea. Okay, there's our rectangular prism. So it tells it's measuring 4 inches and 2 inches along the base. So let's make 1, 4, and this 2, and it is 10 inches tall. So our height is 10. So our volume of a prism, okay, is base times height. Our base is equal to 4 times 2. Our height is equal to 10. Okay, and this is going to be equal to 80. It's pretty easy. Yeah, certainly after the ones you've just been through. Okay. And here we're going to draw a cone. So a cone starts with a circle. Okay, and then you have your pointy part. You can draw your lines. Okay. And this tells us that our radius of the base is 6 feet, and our height is equal to 12, and our formula for the volume of a cone is equal to 1/3 pi r squared h. So I'm going to have this set up times pi times 6 squared times 12. Okay, and when you figure that out, long story short, that should be 452.16. Okay, I got 16 because, again, that's the pi rounding. Okay, and the book got 452.39. Close enough. Okay, so, I didn't put that last one in. I guess you don't need to worry about it. Yeah, that one was pretty hard, so don't worry about the last one. If you have a question about it, I can do it for you in class. So that's it. You're done. This is the last chapter and the last review, and so I will see you soon.